Next principle is 14. Next principle is number 14. So, in principle 14, it stated that a tangent is perpendicular to the radius drawn to the point of a contact. So, for example, this is our illustration of our principle 14. So, if line segment AB is our tangent, if a line AB is our tangent, since tangent is a line that touches a line at one and only one point, so this is our tangent, line AB. If line AB is a tangent, then P then line segment OP is drawn. So line segment OP is drawn. Then line segment line segment OP is perpendicular to line segment AB. Again, in principle 14, it stated that a tangent is perpendicular to the radius drawn to the point of a contact. So if line segment AB, if line AB is a tangent, then OP is drawn, then line segment AB is perpendicular to line segment OP. So that is a principle 14. So in principle 15, it stated that a line is tangent to a circle if it is perpendicular to a radius at its outer end. So for example, this is our illustration. So if line AB is perpendicular to a radius, which is the line segment OP, if ang line AB is perpendicular to line segment OP, then line AB is a tangent of a circle. So this is a principle 15, which is a line is tangent to a circle if it is perpendicular to a radius at its outer end. So if line AB is perpendicular to line segment OP, which is the radius, then line AB is a tangent of a circle. So this is the principle 15. Next is principle 16. So, in principle 16, it stated that a line passes through the center to a tangent at its point of a contact. So, this is our illustration of principle 16. So, if line AB is our tangent, is the tangent of a circle, then line segment CP, if tangent ni siya, if ang line AB is the tangent of a circle, the line segment CP is perpendicular to line AB. Then, line CP extended will pass through the circle. So, in principle 16, again, it stated that a line passes through the center to a tangent at its points to a contact. So, if line AB is a tangent to a circle, then line segment CP is perpendicular to lines AB. Then line segment CP, it will pass through the center of a circle. So that is the principle 16. Next is principle 17. So in principle 17, it stated that tangents to a circle from an outside points are congruent. So if, for example, if line segment AP and line segment AQ are a tangent of a circle, then line segment AP is congruent to line segment AQ. So again, in principle 17, it stated that tangents to a circle from an outside points are congruent. So if line segment AP and line segment AQ are the tangent of a circle, then line segment AP is congruent, then line segment AP is congruent to line segment AQ. So they are congruent. If line segment AP is a tangent and line segment AQ is also a tangent, then line segment AP and line segment AQ are congruent. So that is the principle 17. So in principle 18, it stated that the segment from the center of a circle to an outside point bisects the angle between the tangents from the point to the circle. So for example, if line segment OA is bisects the angle PAQ, then line segment AP and line segment AQ are the tangent of a circle. So again, if the line segment OA is bisects the line segment the angle PAQ, then the line segment AP and line segment AQ are the tangent. So again, the tangent is a line that touches on one and only one point of a circle. So since nag-touch man siya only one ang line segment AP o ang line segment o AQ sa circle with only one, so they are the tangent of a circle. So line segment AP and line segment AQ are the tangent. So that is the principle 18. Next is to principle 19. Stated that a central angle is measured by its intercepted arc. While in principle 20, it stated that an inscribed angle is measured by 1/2 its intercepted arc. So in principle 19, the central angle is measured by the intercepted arc. Well, here in principle 20, the inscribed angle is measured by 1/2. So measured siya 1/2 its intercepted arc. So in principle 21, it stated that in the same or congruent circles, congruent inscribed angles have congruent intercepted arcs. So, for example, if angle 1, if angle 1 and angle 2 are congruent, if angle 1 and angle 2 are congruent, then arc BC and arc DE are also congruent. So, arc BC and arc DE are also congruent. So again, in principle 21, it stated that in the same or congruent circles, congruent inscribed angles have congruent intercepted arcs. So if inscribes congruent angles, so napod siya congruent intercepted arcs. So congruent siya ang angles sa circle, then congruent po siya ang arcs niya. So, angle 1 and angle 2 are congruent. Then, the arcs BC and arc DE are also congruent. So, that is the principle 21. So, in principle 22, it stated that in the same or congruent circles, inscribed angles having intercepted arcs are congruent. So, for example, this is our illustration. So, in principle 22, it converts the principle 3. So, if arc BC is congruent to arc DE, so if arc BC is congruent to arc DE, then angle 1 and angle 2 are congruent. So, this is the principle 22. So, if arc BC is congruent to arc DE, then ang angle 1 and angle 2 is also congruent. So, converse siya sa principle 3. The next is principle 23. So, in principle 23, it stated that angles inscribed in the same or congruent arcs are congruent. So for example, if angle C and angle T are inscribed of arc ACD, then angle C and angle D are congruent. So again, in Principle 23, it stated that angles inscribed in the same or congruent arcs are congruent. Angle C and angle D are inscribed, then angle of the arc ACD, then angle C and angle D are congruent. So that is the principle 23. And so in principle 24, it stated that an angle is inscribed in a semicircle is a right angle. So since angle C is inscribed in semicircle of arc ACD, then the measure of angle C is 90 degrees. So this angle C is 90 degrees. So it forms a right angle or right triangle. So this is the principle of principle 24. So in principle 25, it stated that opposite angles of an inscribed quadrilateral are supplementary. So since ABCD is an inscribed quadrilateral, then angle A is a supplement of angle C. So that is the principle 25. So in principle 26, it stated that parallel lines intercept congruent arcs of a circle. So for example, if line segment AB is parallel to line segment CD, so if kung parallel silang dua, then arc CD is congruent to arc BD. So congruent silang arc CD and is congruent to arc BD. Then if a tangent line FG is parallel to line segment CD, then arc CP is congruent to arc PD. So it is a principle 26. So parallel lines intercept congruent arcs are congruent. So this is a principle 26. So next is principle 27. So in principle 27, it stated that an angle formed by a tangent and a chord is measured by 1/2 of its intercepted arc. While in principle 28, it stated also that an angle formed by two intersecting chords is measured by 1/2 the sum of the intercepted arcs. So it is a principle 28. So next is principle 29. So in principle 29, an angle formed by two seconds intersecting outside a circle is measured by 1/2 the difference of the intercepted arcs. The next principle is principle 30. So in principle 30, it stated that an angle formed by a tangent and a second intersecting outside a circle is measured by 1/2 the difference of the intercepted arcs. While the last principle is the principle 31. So it stated that the angle formed by two tangent intersecting outside a circle is measured by the 1/2 of the difference of the intercepted arc. So that's are the principles of a circle. So there are 31 principles in a circle.